Study Designer, Time to Outcome, Simple Method. For those who wish additional insight into the use of cohorts to evaluate healthcare outcomes, please read Riddles in Accountable Healthcare by Eran Bellin, available on Amazon in both Kindle and paperback. Since you've completed your introduction to Study Designer, let's go and actually build ourselves a study. First, we go to Analysis and left-click on Study Designer. Study Designer opens up, and as you can see, you have no studies here. As you would imagine, you left-click the plus sign, and a study appears. Let's look at the geography of Study Designer. There's a place for a study name. There's a place for you to write your description. There's a place for you to put your cohorts. There is the usual save in, exit, and exit buttons. You notice the three tabs here. This is the main tab, which summarizes the study. The group tab shows you the actual groups you've enrolled in the study, and the method tab shows you the methods. In this case, there are none. Let's build our first study. Let's call that study Pneumonia Readmit. We now have to add some groups. We left-click on the group, and we choose from the drop-down those groups that we want to include. We're going to look at discharges here. We're going to start out with male discharges. We're giving it a name, male discharge. We're now going to add another group. We're going to call this group, you can look for female discharge. Actually, we see we got the wrong group here. It's very important that we get the correct group, the discharge group, because we want the index date pointing to an event that is the discharge from the hospital. We're going to be looking at the amount of time that elapses from the discharge from the hospital to the onset of the next admission. This is female discharge. We're going to make the male discharge the baseline. As you recall, the pneumonia patients were built as people who were discharged in 2010 and discharged alive, not expired. You built those cohorts already from before. Now the method, you're going to add a method, and you notice immediately the method dialog box opens up and asks you what sort of method do you want. I want a time to outcome method, and I'm going to name my method. We're going to name the method TTO admit, which is time to outcome admit. I'm going to add it. Notice what appears immediately. You notice the racetrack paradigm. This metaphor is very useful in understanding how to build a cohort. The metaphor begins with a start flag, like a race begins with a start. You notice that there are a number of days of blackout from the start. There's a number of days we're not going to look for events, but in this case we're starting at the index date at time 0 from the index date. We look over here at the end flag, and the end flag says how much time we're going to be following these patients. We're going to follow these patients 365 days or to their first admission, whichever comes first. And then we have an outcome. Start flag, end flag, going in the forward direction, and an outcome. And that outcome, we have no outcomes here. We want an outcome, so we notice a three-dotted button here. We left-click on the three-dotted button. It opens up another window, the Event Definition Builder, and we'll give it a name, Hospital Admission, or we'll just call it Admission. And for this, the event type is Inpatient Admit, and that's it, nothing more. Save and exit, and here you're seeing this management pane. When I say OK, admission, we'll leave. Now we're going to choose from the drop-down, admission. And as you can see, we have the start flag. We're starting at the index date of each member of the cohort. We're going to follow forward in time to an endpoint, which is 365 days. And we're going to be looking for the first outcome, which is admission. Notice we can go forward, or we can go backward. By clicking on this button, you can go forward or backward. You'll also notice we're evaluating things in days. Of course, the element of time could be months, years, hours, minutes, seconds, but in this case it's days. The method name is TTO admit. The method description is time to outcome. We choose the estimation points. Estimation points are those points in time that are going to be manifest in the table. That is, we're going to get both a graph and a table to look at, so we're going to look at these points at 30 days, 60 days, 90, 180, and 365 days. So the output will actually give us a table at 30 days, 60 days, 90, 180, and 365, and tell us the cumulative percent of people who had at least one admission by day 30, day 60, day 90, day 180, day 365. Completely under your control. We'll give it a name. We'll call this readmission for male, female pneumonia patients. And now we're done. We basically have fully defined the study in this simple method. Now to run it, you just left click on Run. And your results are here. The first step to do, you notice nothing is in the management pane here. You need to save the study. Notice the convention in Study Designer is different from Event Canvas. In Event Canvas, after you built the cohort, you just exit it. But in Study Designer, you actually have to save. Notice what's going to happen over here in the management pane. Let's save it. And you see it appear here. Now we're ready to take a look at the different outputs that are here. First, you have the gender breakdown. As you would expect, the male cohort is all male, and the female cohort is all female. We take a look at the age breakdown. Well, we notice a difference in age. The women are actually older than the men. It's interesting. It almost looks as if women get their pneumonia later than men do. Interesting epidemiologic observation. 6 years here, 20 years here. Okay. Target event. This graph is actually a very useful graph, and one should get used to it. On the x-axis are the number of days that have elapsed from the index date. As you know, everybody starts at their own time zero, and we're following the index date forward in time up to 365 days. On the y-axis, we have the cumulative percent who have been admitted at least once to the hospital. As you can see on this graph, at about 50 days, 20% have been admitted to the hospital again at least once, and by 365 days, about 45% have been admitted at least once. In fact, if we take a look at the table below, remember we had the cut points at 30 days, 60, 90, 180, and 365. Here we have the cumulative percentage of people who were admitted by day 30, among the males, 16%, and among the females with 15.8%. You look underneath the bolded numbers and you have the confidence interval. That is the range of values that you might expect by chance alone if you repeated the study. As you can see, the confidence interval here is between 13.4% to 18.7%, while in the females it's 13.4% to 18.2%. The important point is the confidence intervals overlap, so there is no real difference between males and females at 30 days. In fact, as you go down this list, you see everything actually overlaps, and there is no significant difference. This confidence interval is of the 95% confidence. And we shouldn't be surprised, because going back to our graph, we notice that males are in black and females are in yellow, and they basically overlap perfectly. And the p-value, which is looking at the probability that this happened by chance alone, is 0.5. Remember, statistical significance is 0.05. So there is no statistical significance here, and these patients basically are experiencing the same readmission rate. Of course, as you recall from your demographics, the men are younger than the females, so there is something going on here. But at least once you are comparing the cohorts and you accept those cohorts as comparable, there's no difference here. You notice these straight lines? These straight lines are what are called censorship lines. If a patient does not have enough follow-up time, for example, they're only followed for 3 months, as opposed to 365, then you are censored at that 3 months time. You could also be censored by death, and so you also have a line from that. one would hope that the censorship lines would be basically randomly distributed between the two groups, so they wouldn't be influential. Let's take a look at a tab called All Events. What this does is it counts not just the first event, but the first, the second, the third, the fourth hospital readmission. So the male group had 793 admissions, first, second, third, fourth, while the women had 1,121. However, you have to look at the number of patient days that they were followed. Each patient followed for a year would generate 365 days of risk. The number of male patients that were followed over time generated 242,697 days of risk, whereas the females generated 305,440 days of risk. That is, the time that elapsed from the index date for each patient going forward, 365 days or until they were censored by death or running out of time, generated these numbers of patient follow-up days. Now, when you want to compare the males to the females, you have to stabilize that comparison. We divide 793 by 242,697, and we then multiply it by 365 days to give us what's called an incidence density, which is the number of admissions expected over a year of follow-up. In this case, among the men, it would be 1.193. Among the females, this number divided by that number times 365 days tells us that on average, we would expect to see for a woman 1.34 days in follow-up. We can see these numbers are not the same, but the confidence intervals just barely overlap. However, when you take the relative risk, 1.123, it seems that the women are getting readmitted faster than the men. And the confidence interval here excludes 1.026 to 1.23, suggesting that this is a statistically significant finding, that the women's cohort ends up getting hospitalized more frequently than the men when you look at all the readmissions, not just the first one. When you take a look at the risk difference, which is the risk 1.34 minus 1.193, you end up with 0.147 as the risk difference, and the confidence interval, as you can see, excludes 0. So this is also statistically significant. So it seems that women, by either the relative risk model or the risk difference model, are more likely to be readmitted than the men. It seems as though the women are more likely to be readmitted than the men, and this is statistically significant. You can see everything is being compared to the baseline of the men. That's because the men were chosen as a baseline. As you recall, in our original grouping, we chose baseline males. You could have easily chosen female baseline, and then the inverse would be C. The last, by the way, in case you forget the definitions of relative risk, here is the relative risk, the group divided by the baseline group, and the group minus the baseline group is the risk difference. If you want to take a look at the patient list, you click on this, show that the ethnicity, the gender, the patient name which has been obscured, the primary MD set, the patient phone number, language, race, zip code set, social security number present, whether yes or no. All these things are available to you in the list method. If you actually wanted to see identifiers, you would left click on identifiers and you would be challenged. This is if you had permission to see identifiers. If it's a QA project that you've registered, you would invoke that. If it's an IRB project, you'd put the number in. If it's a patient work list that you're following those patients up to call them back in for a pap test or a flu shot or whatever the reason is, put in the full explanation of what you were doing with the patients that you follow. CLG validation is if you're working with the developers to try to find a bug. The point is the system will record the date, the time, your name, and your very question for future auditing. We're not going to look for identifiers here. Okay, we've shown you the run method. If I want to see the criteria again, I click here, and I get my criteria again. I want to show the results, I click here. If I want to export the data set, that is, I want to output it to a spreadsheet to work with, I left click on export, and I have my choices, Excel 2003, 2007, CSV. I'm going to choose 2007 and export it. Shows me the data file. I left click on that. I choose to open it, allowing it. And as you can see, Looking Glass fully self-documents the entire cohort. Here were the cohorts they originally defined. Inpatient discharge date, pneumonia equals primary only, not expired. Date is 1/1/2010 through 1/1/2011, including the endpoint on the left, that is the 1/1/2010, excluding the 1/1/2011. Gender equal male. Take a look at this summary. This is the other cohort, the women's cohort. Equal female. Summary number 2 is basically the event definition with inpatient admission, and then, which I moved to obscure, date, time, and the information is a limited data set. And now you can use the Excel spreadsheet as you normally would. Let's close, and let's save and exit. Now, if we wanted to share this data set, we just click the share button, just as we did before, and we'd be able to share with a colleague. You'd be able to share with a colleague, and when you share a study with a colleague, you share all the cohorts, all the sets, anything that's necessary to build that cohort, and its report. So it's really a very efficient container to move a lot of data to your colleague who you want to work with. If you want to delete this, you just hit the left click on that, delete yes, but we don't want to. And if you hit PDF, left click on PDF, you will find that everything you've just built in a PDF file that you can share with colleagues. The nice thing about the PDF file is it is de-identified. It has no limited data, it has no identified data, and you can share it very easily. And very often this is used to support conversations in QI departments or IRB applications, because this piece of information or this artifact is completely safe to share with other people. Now, it may include proprietary information of the medical center, but in terms of protecting patient privacy, it's completely safe. Now, if I wanted to open up the study again, I just left click on this pencil. It would open again, and I could begin to do anything I wanted. I could change its name, I could save it with a new name, I could add new groups. Before we leave this tutorial, let me make a few observations. First, the main page is basically the summary page as I showed you. It has the groups and it has the methods. And as you gain additional methods, they'll be plastered on the right side of the page here. The group section can always be added to by adding additional groups. If you wanted to add another group, you could always choose from the additional groups in the drop-down. And if those groups have not already been built, you can use the three-dotted button, left click, and this will open up a window into Event Canvas and let you build a group all over again. Once you finish, you can then exit the management pane and it will bring you back to Study Designer, where you will then be able to pick up the group that you just built. So you have the ability to window into Event Canvas to build a group on the fly. In this case, I don't want it, so I'm going to exit. Another important point in this simple method, let's take a look at the criteria. The reason it's called a simple method is because there are a lot of assumptions built into this model. The first assumption is, if you're going forward to the first event, the first hospitalization, not the last, not the second, but this is a time to the first in the forward direction. If you're going backwards in time, this would bring you to the first admission backwards in time, which happens to be, if you're looking at a whole group of admissions before this admission, it would be the last admission prior. So that's just an important point. It is the most proximal admission that is being picked up, and Study Designer is automatically doing that for you in the simple method. Later, we will show you how to get the advanced method and help you understand what additional powers you have. Congratulations on completing your first study in Study Designer.